which are essential for knowing the sampling methods. So the first terminology, which is population. So population, to be more specific, population means we are talking about target population. So target population is the one which we being the researcher intend to make the inference about. That is, it is a group of our interest. We are making our inference to that particular group. We wanted to make some conclusion about that group. So that is nothing but the target population. Okay. And you need to also note that the population is defined by the researcher. Okay, it is not that the naturally occurring population. So in with respect to sampling, the population is any specific group which is defined by the researcher. Okay, it is not that population of Delhi, population of Karnataka, population of Odisha. No, it is not the one. In sampling, population is a specific group which is defined by the researcher. And population, it need not be always individuals. It can be objects also. Okay, it can be vehicles, it can be buildings, it can be some soil can also be a sample. Okay, so it need not always be individuals. It can be individuals, it can also be objects. Okay, I have an example. So this is one of the populations. All people of North Delhi who are more than 60 years of age. So this is a population which has been defined. That is the population of senior citizens of who are residing in North Delhi. So this is a population. Okay. Sample. So sample is a part or fraction of a population which is selected for our study using appropriate methods. Okay. So a sample should be true representative. So true representative means the characteristics of the sample should be similar to those of the population. Okay, a sample should always be a true representative. It should represent a population. Okay. And as I already mentioned, sampling is the process of selecting a representative sample from the population. Okay, sampling is a process. Okay, and sampling method is a method which is used to select the sample from the target population. Okay, so moving on to the next slide. What is a sampling unit? So sampling unit is nothing but the constituents of the population. Okay, sampling units are the constituents of a population. So these are the units which will be included in the sample. For example, in this example which I showed you, the senior citizens residing in North Delhi are our sampling units. Okay. Sampling units are the ones which are to be included in the sample, which have all the tendency to be recruited or to be included in the sample. Okay, and sampling units can either be individuals or even groups. Okay, we can either select the individuals or we can also select. See, if we are looking into it, so these are the senior citizens who are residing in North Delhi's or population. We can also define our population as the primary schools in North Delhi. Here our sampling units will be schools. Okay. The sampling units can either be individuals or it can be groups or clusters. Clusters are nothing but groups. Okay. Ma'am, is it clear, ma'am? My voice is clear?
Yes,
Because
sir.
I
Yes,
don't get a response from that side. That's why.
yes, sir. It's clear.
Okay, okay, thank you. Fine. So population sample and sampling unit. Sampling units are the individuals or objects of the population which have a tendency of being included in the sample. Next, sample size. As I already mentioned, sample size is the number of units to be included in a sample. Okay. So usually we denote the size of population using capital N, and we use small n to denote the sample size. Small n represents sample size and capital N represents population size. Okay. For example, a population size, a very hypothetical example, assume that your population size is 2500. From this, you are supposed to select 75 individuals. So the population size is 2500 and sample size is 75. Sampling frame. So sampling frame is the list of all the units in a population. Basically, some identifier should be there for all the individuals in the population. Okay. Example, voters list, attendance register. If we want to select the students from a school, so attendance register can be a sampling frame. Similarly, disease registries. So if we are selecting the patients with some particular diseases like cancer registries, their diabetes registries, their TB registries there. So if you want to select the individuals with any particular conditions, we can use disease registry as our sampling frame. Okay, sampling frame is a list of all the units in the population. So all the units will have some identifier. It can be some roll number or some numbers assigned, or it can be their names, or it can be the ideally mobile numbers. So whatever it is, some identifier should be there. Next. So sampling methods are broadly classified into two types: probability or random sampling methods, non-probability or non-random sampling methods. So the commonly used probability sampling methods are simple random sampling, systematic sampling, stratified sampling, cluster sampling, and multi-stage sampling. Similarly, the non-probability sampling methods which are frequently used are convenient sampling, judgment or purposive sampling, quota sampling, and snowball sampling. So these are the commonly used methods. However, there are many more sampling methods available. However, I will be dealing with these sampling methods in today's session. So the first we will see what do you mean by probability or random sampling method. So as the name suggests, so in probability sampling, every sampling unit will have some specific or some designated probability of being included in the sample. That is, the selection of the sampling units is dependent on the probability. So there is no place for the personal judgment or preference of the investigator. So everything we leave it on the chance. So the selection of the individuals is entirely dependent on the chance. So because of this, so the advantage of random sampling is that it will minimize the selection bias, and also it enhances the representativeness. Okay, as there is no role played by the personal judgment or the preference of the researcher, so it will minimize the, if a random sampling is done properly, it minimizes the selection bias, and also it will enhance the representativeness of the sample. Okay. So in this random sampling, the first sampling method which we would be discussing is simple random sampling. Okay, it is the most basic method of random sampling. So this simple random sampling method gives equal probability for all the sampling units to be selected in the sample. It gives equal probability to all of them for being selected. Um, in simple random sampling, so we need to serially list or serially number all the sampling units, and we are and we need to select them. So I will start with an example. So very hypothetical example. Assume that we are supposed to select some 20 individuals from a population size of 250 individuals. So in simple random sampling, what we do is we serially number these 250 individuals, and from these 250 individuals, we randomly select the 20 individuals. So there are some specific methods for selecting the samples in a simple random sampling. The first method is lottery method. In lottery method, what we do is we make, with respect to our particular example, I'll tell you. So we will make 250 chits, and we will serially with some identifier. So we will identify each of the sampling unit. It may be any identifier. Either we can assign 1, 2, 3, 4 up to 250, or we can use their mobile numbers, whichever. But some unique identifier. We will assign some unique identifier to each of these 250 individuals, and we will make some 250 chits for identifying with respect to these 250 people, and we will thoroughly mix those chits, and we will pick some 20 chits. So this is referred to as lottery method. And we can also use random number table. So random number table is readily available, and using the random number table we can generate some 20 numbers between 1 and 250, and we can select those individuals. Similarly, we can use computer to generate the 20 random numbers between 1 and 250, so that we would be able to select these 20 individuals. Okay, so we need to remember that simple random sampling gives equal probability for all the sampling units to be included in the sample. Okay, so the advantages of simple random sampling is it is very objective. Okay, there is absolutely no role for any researchers to uh, introduce their favor or judgment. It is very objective method, and as it gives equal probability for all the individuals, we can say it is very precise method. However, there are some limitations. See, SRS or a simple random sampling can be easily performed for a small population. If your population size is very large, or if you have a very vast population, say I just showed you an example that your population size is 250. Assume that your population size is 2 lakhs. So it is practically very difficult to serially number all the 2 lakh people and do such lottery method or computer generated. So it is very tedious. So simple random sampling is not feasible for a large population. And there is a chance that there might be an underrepresentation of some of the groups. So I'll come back to our example. So assume that we have selected some 20 individuals from out of 250 using simple random sampling. So there can be a chance that 18 of these 20 are males, only 2 are females. So there is a chance that there can be an underrepresentation of some of the groups. Okay, as everything is depend on chance, we can't ensure that we get 10 males and 10 females. This is just one example I am saying. So there is a possibility that there might be an underrepresentation of any particular subpopulation. That's what we can say. So these are the limitations of simple random sampling. And if there are any questions, can you let me know so that I can answer?
No, so till now there is no questions.
Okay,
We
so
can
I
answer the questions at the end, sir. We will collectively, we can do it at the end.
sure, sure,
Okay.
sure.
Thank you, sir.
Thank you, thank you. So I will next proceed to the next. Will proceed to the next sampling method. So again, we'll start with an example. So with this example, so I will demonstrate the next random sampling method. So assume that's a very hypothetical example. So it's not a real example. So assume that there are 16 students in a class. And out of these 16, we need to select 4 of them. Okay. So this is the roll number. So we have serially numbered them, all the 16. And this is their names. So what we do is we calculate a number K, which is population size divided by sample size. So K is referred to as sampling interval. Okay, we'll compute a number K. So in this case, population size is 16 and sample size is 4. So our sampling interval is 4. Okay. Then we will randomly pick a number R between 1 and K. Okay. So we'll randomly pick a number R, which is called random start from between 1 and K. In this case, between 1 and 4. So assume that we randomly get a number of 2. So what we do is we select the first individual, and after this we select every fourth individual. So 2 plus 4 is 6, 6 plus 4 is 10, 10 plus 4 is 14. In this way, we systematically select every kth individual starting from the random start. So this method of sampling is referred to as systematic sampling. Okay. So in systematic sampling, we select the individuals at regular intervals. Okay, in a very systematic manner. Only the starting point we choose randomly, and after that we select every kth individual. Okay, and this systematic sampling is very widely used in household surveys and also in forest surveys. So you might have heard of some very sampling surveys done, no? So NFHS, DLHS, so all this. So they have used this systematic sampling. Okay, very widely used in the large scale surveys. So all this. So as I already mentioned, in systematic sampling, we select sampling interval as population size divided by sample size, and then we select a random start between 1 and k, and after that we select kth individual systematically. Okay, this is referred to as systematic sampling. The advantages of systematic sampling: it is very easy to execute, and we get the sampling unit selected throughout the population. Okay, when compared to the SRS, so we get a uniform representation. That is, you get the sampling units from entire, or the sampling units will be distributed throughout the population. So these are the advantages of systematic sampling. So the limitations being, so we are selecting only the first unit randomly. So after that, there is no randomness involved. So only the randomness is there with respect to the first unit. And again, similar to the simple random sampling, there might be an underrepresentation of some groups. There is a possibility. We can't deny that we get equal representation from all the subpopulations. It need not happen. Okay, it is everything as it is done systematically, depending on the random start. So there might be an underrepresentation from some of the subpopulations. So these are the main limitations of systematic sampling. So let's move on to the next sampling method. So again, I'll start with an example. So a researcher is planning a study to determine the cardiovascular risk factors. So the objective of the study was to determine the risk factors for cardiovascular diseases. So what the researchers did is they divided the population into two subpopulations like male and female. So we have a population is nothing but the people with cardiovascular diseases. So this is the main population. Okay. So what the researchers did is they divided the population into two subgroups, or we can call it as two strata. Okay, and so this is male, this is female, and from each subpopulation they randomly selected the individuals. Okay, so this type of sampling is referred to as stratified sampling. So in stratified sampling, um, the population is divided into subgroups or subpopulations. So these subpopulations are referred to as strata. Okay, stratified sampling. So strata, we divide the population into subgroups, which are referred to as strata, and from each stratum, the individuals are selected randomly. So this is referred to as stratified sampling. Okay. So once you divide the population into subgroups or strata, so for selecting the individuals randomly from each strata, you can either use SRS or systematic sampling. It's up to you. Okay, so from each of the strata, so you to select the individuals randomly, simple random sampling or systematic sampling can also be used. So the advantage, okay, and we follow two approaches in a stratified sampling. One is referred to as equal allocation. Select equal number of individuals from each stratum. Okay. So assume that again I'll go back to our example. So we have a 250 and we are supposed to select 20. So in the sense, you select 10 males and 10 females. So this is nothing but equal allocation. Select equal number of individuals from each stratum. So we have two strata, male and female. From each of the stratum, you select equal number of individuals. So this is referred to as equal allocation. So then is proportional allocation. In the sense, select larger number of individuals from larger strata. That is, larger the stratum, select more number of individuals. Assume that. So in our population, say we have 200 males and we have only 50 females. So what you can do is you can allocate more number of, or out of 20, so maybe you can select 10 males and 5 females, something like that. Okay, so this is referred to as proportional allocation. Okay, so something like maybe we can calculate, so there are 50 out of 250 and we are supposed to select, our sample size is 20, something like that. So we can allocate proportionately. So in this, for males, 150 divided by 250, and we are supposed to, and our sample size is 20. So something like that we can allocate proportionately. So this is called proportional allocation. Equal allocation means we are selecting equal number of individuals from each stratum, whereas proportional allocation means larger the stratum, select more number of individuals from that particular stratum. So this is referred to as proportional allocation. So the advantages of stratified sampling is that definitely it will enhance the representativeness of the sample. So there won't be any underrepresentation of particular subpopulation. And because of this, it eliminates the heterogeneity. It will further reduce the selection bias. Limitations. So we need to have a, yeah, only just the sampling frame is not possible, not sufficient for a stratified sampling. In addition to the sampling frame, so we also need to know the particular characteristics of the individuals. So we need to know some additional information about the sampling units for a stratified sampling. Then only we would be able to stratify the population. That is, once we, in this particular example, if we consider, so we need to, this is our population. So that is, our population is the individuals with cardiovascular risk factors. So for performing stratified sampling, we also need an additional information about their gender. That is, a particular individual is a male or female. So then only we would be able to divide the population. Okay. So it requires additional information about the sampling units. So then only you would be able to stratify the population. And if the number of subgroups is more, so in this example, we had just gender, male, female, others. So assume that you want to stratify based on some religion, or you want to stratify based on the income, or you want to stratify based on their BMI. So if more the number of subgroups, so it would be difficult to stratify, or it is tedious to stratify the population into subgroups. So these are the limitations of stratified sampling. So next we will move on to the next sampling method. So we'll look into an example. A company wants to carry out a survey in a town consisting of 20,000 households regarding the perception of people about the dental care product it launched in the month of June 2019. The town was divided into several blocks, and a random sample of blocks was taken, and all the households in the selected blocks were surveyed. Okay, here you need to pay attention that the sampling units are blocks. It is not the individuals. The sampling units are blocks. Blocks are nothing but groups or clusters. Okay, we are not selecting the individuals or the people, so we are selecting the group of people. Okay, so this sampling method is referred to as cluster sampling. Okay, so in cluster sampling, we select a group of individuals or clusters. Okay, so cluster is a recognizable group of objects or individuals. In cluster sampling, we select the clusters, and all the units within a cluster will be studied. That is, we will be collecting the data from all the individuals within a cluster. Okay, so this is specifically single stage cluster sampling or one stage cluster sampling. So there is a two-stage cluster sampling also, where in the first stage we will randomly select the clusters. In second stage we will randomly select the individuals within the cluster also. So that is called two-stage cluster sampling. So this one, the clusters are sampled and all units within a cluster will be studied is a single stage cluster sampling. Okay, and this cluster sampling is widely used in opinion surveys. So you want to know the opinion about any particular product, you want to know the opinion about a political party, so you want to know the opinion about some newly launched uh, scheme of the government. So in all this we mostly use cluster sampling. Okay, so the advantages of cluster sampling, definitely we can cover a very wide population using the cluster sampling. And even if you don't have a sampling frame, that is for a single stage cluster sampling, you don't require sampling frame. Okay. So single stage cluster sampling can be performed even if there is no sampling frame available. And we can cover a wide or a large population using the cluster sampling. Okay. Limitation. So the individuals within a cluster are likely to be similar, correct? So they will have influence on each other. So if you select all the individuals or the students within a class, so they tend to have some influence on each other. They tend to share some common interests. So this is referred to as a group effect or a cluster effect. So because of this, so the efficiency of cluster sampling is less than other random sampling methods. Okay, so this is because of clustering effect. Okay, so if you, because of this cluster effect, what happens is after you perform the analysis, so the variability will be less. So because as the individuals have influence on each other or they tend to share some common opinion, so the variability will be less, so this will lead to some false significance. So this is the limitation, or this is a consequence of this clustering effect. So it might lead to, after you collect the data and perform the analysis, so the variability will be less. So this might lead to false significance. We might tend to present significant results even though there might not be any statistically significant difference. So to prevent this, what we do is we increase the sample size if there is cluster sampling. So I will give more details on this during the sample size estimation session. So the disadvantages of cluster sampling is, so the efficiency of cluster sampling is less than other random sampling methods, SRS or stratified or systematic, because of the clustering effect. And to prevent this, or to, as a precautionary measure, what we do is we enhance the, or we take an increased sample size if we are performing cluster sampling, or if we are using cluster sampling, we deliberately increase the sample size. So that I will tell you more when we are doing the session on sample size computation. So I will move on to the next sampling method. So the research question is to study the attitude of school children of North Delhi towards hand washing. So what we do is, in a first stage, we will select the random sample of schools from each tal. In the second stage, we select random sample of classes in each school. And in the third stage, we select random sample of children from each selected classes. Okay. In the first stage, we selected the schools. In the second stage, from the selected schools, we selected the classes. And in the third stage, from the selected classes, we selected the children. So that is, we did sampling in 3 stages. So this is referred to as multi-stage sampling. Okay. So it is a very complex form of sampling, so which is used to cover a large population. If it is a state level survey or if it is a national level survey, so multi-stage sampling is used, where the sampling units are selected at several stages. Okay, that is more than 2 stages. If the sampling is done more than 2 stages, it is referred to as multi-stage sampling. Or to be specific, if sampling is done in more than 1 stage, it would be multi-stage sampling. Okay, so it is mostly used to cover a large population. Okay. So with this, we have covered the random sampling techniques. So if you have any questions, you can drop in the chat box. I will answer. So then we will move on to the non-probability sampling methods. So if there are any questions, ma'am, I would.
Yes, sir.
Yes, ma'am.
Difference between randomization and random sampling.
Okay. So random sampling means we are picking something. Okay, we are grabbing, we are selecting. So randomization means we are allocating them to different groups, maybe treatment group or control group. So I would say random sampling is randomly picking, randomization means randomly throwing. So that's the difference, picking and throwing.
Is underrepresentation of subpopulation will affect the result of the study?
Definitely it would be a limitation of your study. See, the main principle of sampling means you should have a representative sample. So you need to generalize your finding to the entire population. If your sample is underrepresented, or if there is an underrepresentation of any particular subgroup, so it will be a limitation of your study.
Sir, which type of sampling is used for descriptive study?
Descriptive study, mm, yeah, there is, it depends on the resources available, I would say, in the sense if you can go for a mostly descriptive, if your population is wide, so you can go for two-stage sampling, or if you are doing it into, like, you can also go for a systematic sampling, in the sense you can divide into urban and rural, something like that you can select, or you can go for a systematic sampling also to cover a wider population. So mainly the choice of sampling methods depends on the size of the population and the resources available with the team.
Okay, so disadvantages of cluster sampling.
So already mentioned. So the in a cluster sampling, so the individuals within a cluster have an influence on each other. So they tend to be similar. So this is called clustering effect. So because of this clustering effect, so the efficiency will be less than other random sampling methods. So once you perform the collect the data and perform the analysis, so this might give you a false statistical significance as the variability is less. So this is the limitation of cluster sampling.
Sir, how to collect cluster randomized control trial sample?
Oh, again, so this is a different thing. So in cluster randomized trial is different, cluster sampling is different. So in cluster randomized trial, what we do is, so we will have a list of our clusters. Okay. Then we will randomly allocate our clusters into treatment group and control group. Here in cluster randomization, we will not be selecting the clusters. Rather, we will be allocating the clusters into experimental group and control group. So you need not pick the clusters randomly in a cluster randomized trial. However, you will be randomly allocating them to uh, treatment group and control.
So is there any measures to rectify underrepresented sample in a study?
There won't be any measure, but once you select the sample, you can, once you collect their descriptive information, so you will definitely come to know, once you take out the frequencies, you will come to know based on the descriptives. Once you collect the data from the selected individuals and you perform the descriptive analysis, so you will have an idea.
How to decide proportion for allocation?
Yeah, there are two approaches as I mentioned. So one is equal allocation. We can select equal number from each of the subpopulations, or else allocate them proportionately. Okay. So I told you, no. So something like Ni by capital Ni into N. So this N is the sample size. So this is the sorry sir, just a second. Something we want to know number of individuals we need to select from this one. So we can select like Ni by N into small n, or nothing but So this is the number of individuals to be selected from ith stratum. This is our sample size. This is the total population size. This is the size of that ith stratum, population, ith population size. So this is total population size. This is our sample size. So something like that we can proportionately allocate.
Uh,
Larger the stratum, select more.
if population is less for qualitative study, then what type of sampling is beneficial?
That I am coming. So for the qualitative study, which is the sampling method, so that I am coming. So I will be discussing in the non-randomized sampling methods.
Okay, yes, sir. Um, some of the participants has asked to repeat some topics. I request the participants to please click on to the YouTube link and understand whatever sir has taught already. Please understand at your own pace, because it will consume more time if we will repeat all the top content whatever sir has already explained. Sir, strata should be limit with location, setting, or number.
Strata need not, I would say it would be any characteristic. So stratum, we decide the strata based on any characteristic which we are interested. It is not any setting or location. It is mostly the characteristic of the population.
Only allocating in RCT lottery method is not needed.
Yeah, so lottery method is a method of random sampling. It is not a method of randomization. So in randomization, we have simple randomization and we have block randomization, we have stratified randomization. So that is different. So lottery method is nothing to do with randomization.
Yes, sir. Other questions, or they are asking to explain again, that they will refer from the YouTube link. So we can proceed to the
Yes,
next.
thank you.
Thank you,
So,
sir.
in general, so the advantages of probability sampling methods are, so they will enhance the representativeness of the sample and they will reduce the selection bias. So, in general, these are the advantages of the random or probability sampling methods. So next we will move on to the non-random sampling or non-probability sampling methods. So as the name suggests, non-probability sampling means we select the individuals in a non-random manner. That is, we in a probability sampling, so we leave it to the chance. That is, we assign some probabilities to the sampling units for getting selected. So whereas in non-probability sampling, so we select it in non-random manner. It might be based on the ease of availability. It may be based on some personal preference of the investigator. So all this, but non-random. So because of this, it is prone to selection bias. So definitely non-probability sampling methods are not as accurate as probability sampling methods. In non-probability sampling method, so first we will be discussing convenient sampling. So convenient sampling, as the name suggests, we select the sampling units based on ease of availability or accessibility. So we don't do any serial number reallocation, lottery method, or stratifying systematic, nothing. So based on our convenience, based on the ease of availability or accessibility, we select the sampling units. So for example, the researcher aims to study occupation hazard. So the researcher may go to the nearby industry and interview a few who are available. Or the studies which happen in a hospital setting. So they go to OPD. So whoever is willing, whoever give the consent, select them. So based on the availability, ease of availability, accessibility, you select the sampling units. So this is convenient sampling. So the next one is judgment or purposive sampling. So this is mostly used in qualitative research. See, in qualitative research, we interview a specific group of individuals. Assume that we want to know the perception of HIV positive individuals who are suffering with TB. So in such case, so we have to select the individuals with some specific condition, that is HIV positive people who are suffering with TB, any particular condition. So this is mostly used in qualitative research. Okay, researcher selects a sample deliberately or purposefully. We have a purpose. We wanted to know more on the HIV people, positive people who are suffering with TB. We wanted to know the social stigma. We wanted to know how what is their perception about life. So all these things. So in such cases, we select such individuals. So which is judgment or purposive sampling, widely used in qualitative research. So the next non-probability sampling method is quota sampling. So the quota sampling is a non-probability equivalent of cluster sampling. So I hope you are familiar with the term quota. So while you are taking admissions, so there might be some quota, no? Like if there is a sports quota, there is NCC quota, there is rural quota. So all this, you are very familiar with quota. So much percent is reserved for the students who are from sports quota. So much percentage of seats is reserved for the students from rural background. So much percentage is for the children of army personnel. Something like quota means some percentage is reserved. So in quota sampling also, we allocate some percentage, like we will be dividing our population into some specific subgroups based on some quota, and we select the individuals from each subgroups in using non-random sampling methods. For example, to study the work satisfaction of cleaning staff of a hospital, a sample of 500 will be drawn. So in that 300 females, 200 males. So something like we will divide based on some percentage quota. So male quota, female quota. So 300 females, 200 males. Something like that. It is a non-probability equivalent of stratified sampling. So we divide our population into subgroups. However, we select the sampling units non-randomly. The last sampling method which I would be discussing is snowball sampling. So snowball sampling is mostly used in studies involving hidden population. So hidden population means this LGBT community or drug abusers, sex workers, all this, in the sense we don't have a ready-made sampling frame, or criminals. So all this. So they won't see nowadays. Definitely LGBT are coming out in open, so they are not hidden. So maybe the drug addicts, so sex workers, so all this. So you will not find a well-defined sampling frame. So what we do is, first we identify one such individual. So from that individual, we will ask him to nominate his or her friend. So we recruit that individuals from that particular person, one more. So like that, we build a network. So that's why it is called respondent driven sampling. So the individuals themselves, they will help us in identifying the other individuals. So we don't have any sampling frame, or we don't even know where they are. So we will identify them using their friends only. Okay, so if particular, like for example, we identify one drug abuser, so we will collect the information from that person and we will ask him, can he show his friends? So like that we build a network. Why the name snowball sampling is given? Because it is something like, if you put a small ball over a snow and roll it, as the ball rolls, so it will get bigger and bigger. So similarly, we recruit one particular individual, and from that particular person, so we will recruit others. So that's why it is referred to as snowball sampling. It is respondent driven sampling. Okay, mainly used in hidden populations. Okay. So in general, why we need to go for sampling? So it is definitely, it saves our resources, money, manpower, and we can study the sample thoroughly. So as the size is small compared to the population, we can investigate the sample thoroughly. And if it is a large population, so studying the entire population may be difficult. So whereas you can study a sample thoroughly. And if your study is destructive, if the study is destructive, so in the, for example, if you want to know how long a bulb survives, or like you make a material, so you want to know how strong it is. So in such cases, if the study involves destruction of something, so then sampling is inevitable. So we need to go for sampling. So we can't think of destroying the all the units in a population. So we just take a sample of the representative sample and we um, perform the study and we later generalize. Okay, sampling is inevitable if the study is destructive. Okay, it involves some destruction. So limitation. So sampling requires the services of trained and qualified personnel. So you need to have some uh, team which has some experience of doing the study, and you need to execute, plan and execute the sampling carefully, or else it might lead to some misleading results. So these are the some common advantages and limitations of sampling. Okay, so with this, I have covered some commonly used sampling methods. So after this, we will move on to the sample size estimation. So if you have any questions, so I will clear this and then we will move on to sampling methods. Sorry, sample size estimation.
स्टूडेंट्स का प्रोग्राम है सर, नया स्टूडेंट्स का फ्रेशर्स
If you have any questions, so I would be happy to answer.
well usually in the morning only we keep 10 to 12 o'clock 2 hours.
Excuse me, ma'am. Are there any questions, ma'am, in the chat box?
What he said?
Any questions, ma'am, in the chat box?
So there are some, but can we do it at the end?
Yeah, because the next topic I would be moving on to a entirely different topic, so I prefer
To take the
answering the
questions now.
question.
Yes,
Yes,
sir. In multi-stage sampling, can we use different sampling methods at all stages, or it should be same at all stages?
yes, you can use different sampling methods at different stages.
Difference between cluster and multi-stage sampling.
So cluster sampling is a one-stage sampling. So if you use like in a cluster sampling, you randomly select the clusters and you study all the individuals within a cluster. So if you do a cluster sampling, and in the second stage you also randomly select the individuals within a cluster, it will become a multi-stage sampling. Okay, so basically if you are performing any sampling method at more than one stage, it becomes a multi-stage sampling.
Uh, One participant has asked, can we select the colleges in India by purposive sampling technique?
Ideally, to you see, your population is very wide. You are selecting the colleges in India. So if you go, definitely you can select by purposive sampling, but it would add means the study will have a good weightage if you go for random sampling methods than purposive sampling.
Uh, when we don't have availability of people,
Mhm.
which sampling method should be used?
Available. No, then there can't be any sampling. Then there are no individuals available, then there would be no study.
When maybe they want to say they couldn't, the less sample size, maybe that is what they are meaning, that not.
So then you can, if there are no individuals, then you can do a simulation study. That's all.
Difference between strata and quota.
Yeah, it is same in the sense quota is also nothing but you are dividing the population into different subgroups. But in quota, you fix some proportion in the sense 30%, 60%, 20%, something like based on some definite proportions. You will be dividing you will be recruiting the individuals non-randomly from each of the strata.
Can quota sampling be used in descriptive study?
Yes.
How to decide a quota in a quota sampling?
So it depends, again, depends on the population, how it is. Again, you need to know the characteristics of the population.
Uh, how to calculate a sample size for snowball sampling?
No, there is usually we don't calculate the sample size for a snowball sampling because we are not sure. No, we don't even know how many are there. We don't even know the population size. So mostly you can calculate, but we are not sure. Like, see, you calculate one number, but you are not sure that you will be able to make it up. So many, so it's unsure.
Can we use snowball sampling method in descriptive study design?
Again, see, snowball sampling you can use, but ideally snowball sampling is used. I mentioned, no, it is for some hidden population. So where you don't have a well-defined sampling frame. So inside, definitely you can use. So if your population is hidden, so definitely you can use snowball sampling for a descriptive study.
One participant has asked how we can call snowball sampling. Sir has explained why it is called as snowball sampling. So I request you to please refer to the YouTube link to understand that same. And some have again asked to repeat the topics that you can refer to the YouTube link. So can we use two sampling methods together, like snowball and random?
No. See, you can use stratified and systematic or stratified and SRS, but not non-random with a random. No.
So one participant has asked, where does consecutive sampling falls?
Consecutive sampling, I think this is more in a quality control. So in quality control, what we select lots. Like if you want to study any industrial material, like maybe clothes or whatever it is. So we want to study their quality, how good it is. So there mostly we use this consecutive sampling.
Then one participant has asked, in RCT, 250 college is there in urban and rural, and how to select the students?
How to select in RCT? Again, it is you need to decide whether you will be going for cluster randomized study or if it is an individual randomized study. So in RCT, sampling may or may not be there, but randomization should be there. So even though you may not randomly select the individuals, but definitely you would be randomly allocating the individuals into your treatment and control groups. So first you need to decide whether you will be doing a cluster randomization or individual randomization.
So the same person has added further, like in cluster randomized control trial, sample from urban and rural should be same or different.
Sample from or again. So in randomization, there are I mentioned no, there would be a simple randomization, block and stratified randomization. Definitely, if he wants to consider this rural urban criteria, then he can go for stratified randomization. So in stratified randomization, he or she can decide like in treatment group, how many colleges of rural, how many colleges of urban, like that. They can go for stratified randomization.
In non-experimental study, what type of sampling technique can be used?
Non-experimental, you can use either random sampling also can be used in non-randomized study. Random sampling or non-random sampling.
In multi-stage cluster sampling methods, subgroup selection can use lottery method selection.
See, ideally, multi-stage sampling is used to cover a very wide population. So, lottery method and all may not be feasible in multi-stage. So, mostly it will be a combination of cluster sampling and systematic sampling, mostly.
There are some questions related to estimated sample size that
Yes,
sir will cover in the coming up slides.
yes,
That's
yes.
also.
Yes, ma'am. Thank you so much, ma'am. So next we will be moving on to sample size determination. So till now we discussed on how are we selecting the individuals. So now from this slide onwards, so we will be knowing on how many are we selecting. So this sample size determination, so it requires some formula to be used. So there is no single formula for determining the sample size for all the situations. So basically the sample size determination, it depends on the objective. It will vary from objective to objective. Okay, so in this session, I will be first telling you why do we need to go for sample size determination. Then I will show you the sample size computation for different situations. Estimation of mean, estimation of proportion, comparison of two means, comparison of two proportions. And I will tell you some sample size adjustments to be made for non-response and T-side. Okay, so you need to remember that there won't be any single sample size formula for all the situations. So sample size computation or the formula to be used for sample size computation, it depends on the primary objective. It varies with the objective. In the sense, for a descriptive study, you will be using one particular sample size formula. For comparing between two groups, there is a different sample size formula. So like that. So mainly the sample size computation depends on the primary objective followed by the nature of your outcome variable. Okay. So important determinants of sample size are our primary objective and primary outcome. Nature of our outcome, whether our outcome is continuous or it is dichotomous. So like that. So it depends. Okay. So now let us discuss why do we need to go for sample size computation. So what is the need? Why can't we just select some number? So why we need to do this exercise? So these are the main reasons. So it can be, there can be many reasons, but these are the main. To keep a check on type 1 and type 2 errors. So assume that, so we require 50. Okay, 50 individuals are enough for your study, but you select 200 of them. Okay, so I hope you know what is type 1 error and type 2 error. So in situation 2, so your study requires 200, you just recruit 50. So we'll see here what happens. So in this situation, if you select more than required, what happens is you may end up rejecting the null hypothesis even for a small difference which may not be clinically relevant. You may be saying that even if you get a very small difference which is not clinically important, you may say that the result is statistically significant. That is, you will be rejecting a null hypothesis which is false. Correct? Even though there may not be any difference, clinically relevant difference between the two groups, you reject the null hypothesis and say that there is a difference. In the sense, you are more likely to commit type 1 error. That is, if you are selecting too many than required, you are more likely to commit type 1 error. Okay. In situation 2, you select too few than required. So you may end up accepting the null hypothesis even though there is a difference. Okay. In this case, you are more likely to commit type 2 error. Okay. If you select too many than required, you are more likely to commit type 1 error. If you are selecting too few than required, you are more likely to commit type 2 error. Okay. So for this reason, to keep a check on type 1 and type 2 errors, so we are required to compute the sample size. So I will show, or I will tell you, so how we are computing the sample size for a given level of significance and a power. So I will tell you. And to prevent wastage of resources. See, 50 are enough for your study, you are recruiting 200. So unnecessarily, you are troubling those extra 150 individuals. So assume that they may have any side effects or adverse events. So unnecessarily, you are putting the individuals at risk. So again, ethically, this is not correct. Okay. Similarly, 200 are required, you are selecting only 50. So you know that this study will not give you anything. So still you are wasting your time and resources and the time of these 50 people. So to prevent the wastage of resources and also ethically you are not supposed to unnecessarily trouble the individuals. So because of these reasons, you are required to compute the sample size using appropriate sample size computation techniques. So as I already mentioned, so important determinants of sample size is the primary objective and nature of the primary outcome variable. Prerequisites of the sample size computation. So before stepping in to compute the sample size. So what are the preparations to be made from your side? So one is your primary objective should be well defined. That is, your research question should be clearly stated, and your primary objective should be clearly stated. And your primary outcome variable should be well defined, whether it is continuous or whether it is categorical, what is the unit, whether it will be normally distributed or it is more likely be skewed. So all this, so you need to have some prior knowledge or prior idea of this. And you need to identify your parent article. Okay. If in case your parent article is not available, parent article means already published similar article, the study which is similar to your study, which is already published, is called parent article or key article. If in case this is not available, so you can go for a pilot study. So what is the use of these two? Why we need to have key article or a pilot study done? So we need some inputs for the computation of sample size. See, sample size is not a magical number which you just pull out from a air. So it requires some inputs for computation. That is, inputs are standard deviation. You might require the standard deviation or anticipated proportion and margin of error or clinically significant difference. So I will tell you more on this. So how these are required for sample size computation. So I will be telling in the upcoming slides. But you need to understand that so sample size computation is a collaborative activity. In the sense, you need to, it is a collaboration between the researcher and a statistician. It is not the sole responsibility of the statistician to compute the sample size. So if there is any mistake in the sample size, the researcher should be blamed rather than the statistician, because researcher is the one who is supplying the inputs for sample size computation. So before attempting the sample size computation, so the researcher should do adequate background work for sample size computation. Okay. Yes. So first we will go through an example. The objective of the study was to estimate the average weight of anemic women in a particular age group of 25 to 30 years who are residing in a particular district of UP. Okay. And the study design is descriptive. You can see that it is clearly descriptive study. Okay, in the sense it involves single group. No comparison is there. We are not doing any comparison. In the sense, we are not doing any hypothesis testing. We are just estimating. We are saying that after the study, the researchers may conclude that the average weight of the anemic women is so and so with a standard deviation of so and so. It is just estimation. There is no hypothesis testing involved. Okay. And you can note that the outcome variable is a continuous variable. It is weight. Weight is a continuous variable. For a qualitative variable, in qualitative, it is continuous variable. So we need to compute the sample size for this particular study. See, here we are considering two things. One is the study design or the objective, and nature of the outcome variable. So we are not based on any, like, what I meant is we don't consider the sampling method. while deciding the sample size formula. Okay, it depends mostly on the objective and study design and the nature of the primary outcome variable. However, we may make some modifications to the computed sample size based on the design. So that I will tell you. So the sample size is as follows. So this is the Z value at a some percentage level of confidence. Okay. Z value at 1 minus alpha into 100% confidence level. Okay. So this is mostly we use confidence level of 95% or 99%. Okay, that is if we are we constructing 95% confidence interval, or are we constructing 99% confidence interval, that we need to decide. If we are constructing 95% confidence interval, so the Z value is 1.96. If we are constructing 99% confidence interval, the Z value is 2.58. So these are the standard values obtained from normal distribution. These are the standard values. Okay. Most commonly, we use 95% and 99%. And sigma is the anticipated standard deviation of the primary outcome variable. Okay. So this is obtained from the previous study or pilot study. Okay. And D is called margin of error. Okay, D is margin of error, amount by which the result from the sample is expected to differ from that of the population. Okay, if you are assume that you are doing a complete enumeration of the population, so you get one mean, then you do a sampling and you compute a mean from the sampling. We have population mean, we have sample mean. So what is the difference? What is the expected difference? Amount by which the result from the sample is expected to differ from that of the population. It is just anticipated. So it need not be actual because you never know. It is anticipated. Again, it is decided by the investigator. Okay, an investigator has to decide this. Okay, so let's plug in the inputs. So it is, they say that 95% confidence level. So the Z value is 1.96. And here they gave the weights of women in the age group are normally distributed with a standard deviation of 12. So sigma we have 12. What is the minimum sample size required at 95% confidence level, assuming that the sample mean will not differ from the population mean more than 2.4? So D is 2.4. If we plug in these inputs, so we get a sample size of 97. Okay. So these 97, so you can use any of the sampling methods to recruit these 97 individuals. So this, what I meant is, this sample size formula is irrespective of the sampling method. Okay, however, I will tell you in the upcoming slides, if we are using cluster sampling, we need to do some adjustment to the sample size. So that I will tell you. Okay, so we found that the sample size is 97. So we will move on to the next example. To estimate the prevalence of TB among women in the age group of 40 to 60 years in the Bagalkot district of Karnataka. Study design descriptive. You need to pay attention here. You can see that here the outcome is categorical. Specifically, it is dichotomous, yes or no. TB present, TB absent. See, in our previous example, our outcome was continuous, it was weight, whereas here the outcome is binary, yes or no. Okay, so the sample size formula goes like this. The only change is instead of sigma square, we have p into 1 minus p. Okay, other these things are same. 1.96 or 2.58, and this is the margin of error. Instead of standard deviation, here we have anticipated prevalence. So you need to refer to your previous articles or do a pilot study, and you need to come up with the anticipated prevalence of the event in the population. So if you know this and plug in the inputs, so you would be able to compute the sample size. Let's see. Determine the minimum sample size required to estimate the prevalence of TB among women in the age group 40 to 60 years in this district, assuming an anticipated prevalence of condition to be 25% at 95% confidence level and 5% margin of error. See, here we get the Z, here we get the P, here we get the D. So if we plug in the inputs 1.96 square into 0.25 into 1 minus 0.25 divided by 0.05 square, we get a sample size of 289. So we need to recruit 289 individuals for this study. Okay. So you note that. So these two examples were for a descriptive study. That is, both these examples we had only one group in the study. We didn't do any comparison. It was just estimation. Okay, we estimated you with some particular level of, we estimated in the first example, we estimated the mean with a some level of confidence. In the second example, we estimated a proportion at this particular level of confidence. Okay, remember that we did not do any comparison. That is, these two examples, in these two examples, the study did not involve comparison. So I will move on to the next example. To compare the effect of a low fat diet with a usual diet. Okay, we have two groups. So one group is low fat diet and another group is usual diet. Okay, we are doing some comparison. So this particular study involves two groups. Experimental group is low fat diet and control group is usual diet. Study design RCT, and look at our outcome, total cholesterol, which is a continuous or quantitative variable which is continuous. Okay, so basically we would be comparing the average total cholesterol of individuals who are taking low fat diet with average total cholesterol of individuals who are taking usual diet. Basically we are comparing the mean of two groups, correct? We are comparing mean of two groups. So for the analysis, we would be using an unpaired t-test or two independent sample t-test, what we call. We would be using an unpaired t-test for analysis, correct? If we are analyzing the data, we would use unpaired t-test. So this is the sample size formula for unpaired t-test. Okay, sample size for comparison of means, or you can call it as sample size for unpaired t-test. Okay, see here we get one additional component. See, previously we had only this Z value at particular level of confidence, whereas here we call it as Z value at alpha level of significance. In the previous examples, we used confidence levels, so we did not use the term level of significance. Okay, please understand. Level of significance we are using because it involves hypothesis testing. So our null hypothesis may be mean of group 1 will be equal to mean of group 2. Alternate hypothesis. Mean of group 1 not equal to mean of group 2. So there is some well-defined hypothesis. So we use the term level of significance. This Z1 minus beta, Z value at 1 minus beta percentage power. Okay, ideally we use 5% level of significance or 1% level of significance. Power we use 80% or 90%. Okay, because this combination, you might ask why 5%, 1%, 80%, 90%, because this is the combination which gives maximum sample size. Okay, see this, you know, Z value at 5% level of significance is 1.96. Z value at 1% level of significance is 2.58. It is same. Previously, Z value at 95% confidence level we used 1.96. At 99% confidence level we use 2.58. Okay, the terminologies are different. In estimation cases, we use the term level of confidence, whereas here in studies which involves hypothesis testing, we use the term level of significance. Okay. Power, Z value at 80% power is 0.84. Z value at 90% power is 1.28. Okay, these are the standard values. You can remember 1.96, 2.58, and 0.84, 1.28. So these are the standard values. So sigma, you know, anticipated standard deviation of the outcome variable. Okay, so this you can get it from your parent article, or you can do some pilot study. Okay, sigma you can get it from parent article or from pilot study. D. Say in our previous two examples, we called it as margin of error. Okay, as we had only one group, we compared our result with that of a population. So we anticipated the difference, that is from sample with population. Whereas here we call it as clinically significant difference. That is, what is the minimum difference between the two groups which is considered as clinically relevant. Okay. In previous two cases, we called it as margin of error. Here we call it as clinically significant difference. It is the minimum difference between the groups which the investigator considers as clinically relevant. Again, decided by the investigator. Okay, you need to remember there is a difference with respect to the terminologies. One is D, in estimation case, we call it as margin of error, whereas here we call it as clinically significant difference. And Z, and there we call it as level of confidence. Here we call it as level of significance. Okay. So let's plug in the inputs. What is the sample size required in each group to detect a difference in total cholesterol of 20? See, D is 20. Between the two groups with 90% power. So 90% means it is 1.28 and 5% level of significance, 1.96. Based on the previous study, in similar population, the standard deviation is 35. So sigma is 35. Is it fine going on? Am I audible?
Yes, sir.
Okay. Sorry. Yeah, we'll carry on. Okay. So we have all these inputs. So we will plug in. And you need to note that N is sample size in each group. Okay. You can see N is sample size in each group. Okay, there N is in the estimation problem, N is total sample size, whereas here N is sample size in each group. Okay, so we will get, if we plug in the inputs, standard deviation is 35, clinically significant difference is 20. At 5% level of significance, 90% power, we get approximately 65 individuals per group. Total sample size will be 65 plus 65, which is 130. Okay. So this is sample size for comparison of two means. Okay. So now go through this example. Objective of the study was to compare the proportion of cancer patients suffering from relapse within 6 months under two treatment regimes. Okay, here also we have two groups and we are comparing the proportion. Okay, so basically you can, which is the test which is used to compare two proportions? It is a chi-square test. Okay, Basically, you can say this is the sample size formula for 2 by 2 chi-square or chi-square which involves 2 by 2 table. Okay, so basically here we have two groups, group 1, group 2. Sorry, here group 1, group 2. We have relapse S no. Okay, something like that. We will be making a 2 by 2 table. So it is a chi-square test with for 2 by chi-square test for 2 by 2 table. Okay, and you can see our outcome is a dichotomous outcome S no type. Okay, please compare with the previous example. In previous example we were comparing the mean of two groups. The outcome variable was continuous, whereas here we are comparing the proportion in two groups. So the outcome variable is categorical, specifically binary. Okay, so this is the sample size formula. Okay, so this you know it is same. Z value at alpha level of significance, Z value at 1 minus beta percentage power. Here it is 1.96 or 2.58. Here it is 0.84 or 1.28. So these two are standard. P1 and P2. P1 is prevalence of event in the first group. P2 is prevalence of event in the second group. Okay. These two you will be getting from the parent article, or you can, if possible, you can go for a pilot study. Okay. Yes. So we have this. A researcher intends to compare the proportion of cancer patients suffering from relapse within 6 months under two treatment regimes, with a 50% relapse rate in standard treatment and 34% under new regime. That is, P1 is 50%, that is 0.5, and P2 is 34%, that is 0.34. Okay, so let's plug in. They have given 5% level of significance and 80% power. Okay, so I'll do it here. P1 is 0.5, P2 is 0.34, so P bar is 0.5 plus 0.34 by 2, which is 0.84 by 2, which is 0.42. So N is again sample size in each group, 2 into 0.42 into 1 minus 0.42 into 1.96 plus 0.84 whole square divided by 0.5 minus 0.34 whole square. So if we do this, so we will get sample size in each group. So I can tell you how much we get it. Let me calculate. So we will get approximately 150 per group. Okay, we will get sample size of 150 per group. Okay. So now we need to make some adjustments to the sample size. One is dropout rate or non-response rate. See, in these two examples are RCT. So these two examples are definitely RCT. As they involve some follow-up and all, definitely there will be some dropout. So what we do is we anticipate the dropout during the sample size calculation only, and we increase the sample size as a preventive measure. Okay, assume that commonly we use dropout rate of 10%, 15%, or 5%. So we don't, mostly we don't go more than 20%, commonly 10%, 15%, or maximum of 20%. We don't go more than 20%. So for this particular example, so put the, we will account a dropout rate of 10%. See, we have computed N as 150. 10% dropout rate, 1 minus 0.1, which is 150 by 0.9. So we will be, increased sample size will be 167 per group. Okay. After accounting for the dropout rate of 10%, our sample size would be 167 per group. It is always advisable to account for a dropout rate if you are doing a prospective study, or if you are doing a survey, it is a descriptive study. It is always advisable to account for non-response rate. Okay. Another modification, sample size for non-parametric test. Okay. Assume that your outcome variable is quantitative. Okay. Outcome variable is quantitative. You know that. However, by the nature of variable, you know that you would be going for a non-parametric test. Okay. Assume that your outcome is some counts. Number, it is a number like platelet count. Assume that, for example, your outcome variable is platelet count. Okay. And you have two groups. Okay. And your outcome variable is platelet count. You know that you would be applying a Mann-Whitney U test. You know, in the beginning itself, you will come to know that you would be applying a Mann-Whitney U test. So what you should do? So you can compute the sample size using sample size formula for unparity test and increase the sample size by 15 to 20%. Okay. You know, no, that non-parametric tests are less powerful than parametric tests. So you compute the sample size using sample size formula for unparity test. However, later you increase the sample size by 15 to 20%. Next, if your study is involving cluster sampling or cluster randomization. So I already mentioned during the session on sampling methods. So I mentioned that there would be clustering effect. So the efficiency of cluster sampling is less than other random sampling methods. So what we do is we multiply the computed sample size with 1.5 or 2. As a rule of thumb, we multiply the computed sample size by 1.5 or 2 as a precautionary measure. I told you, now after you collect the data and do the data analysis, it might give you a false significance because the variability will be less. So in order to prevent this, you increase the sample size by 1.5 or 2 if your study involves cluster sampling or cluster randomization. Okay, so I briefed you with the sample size computation. So I showed you what is the principle behind the sample size computation. So however, if you know the background, how to compute the sample size, so you would be able to do the sample size computations for other scenarios. See, I showed you the sample size for estimation of mean and proportion. So there will be the sample size estimation for sensitivity, sample size estimation for specificity. Similarly, I showed you sample size computation for unparity test, sample size computation for chi-square test involving 2 by 2 table. So there is a well-defined sample size formula for parity test, for one-way ANOVA, for correlation, for regression, for testing odds ratio, for testing relative risk, so many. So sample size computation is a very vast topic. So however, I have showed you the basics of sample size computation. So if you are familiar with this, so you would be able to do the sample size computation. You can refer to books and you can do the sample size computations. Okay, so the message is clear that sample size computation, it involves some formula and you need to plug in some of the inputs for computation, and the sample size formula, it varies with the objective and it varies with the nature of the primary outcome variable. So finally, so this is the one of the good reference books, so which you can consider buying. So this is one of the good books in biostatistics. You can definitely consider buying this. And thank you very much for your attention. If there are any questions in the chat box, so I would be happy to answer.
So yes, sir. Thank you so much, sir. Thank you so much. It was very elaborative session. You have elaborated the nicely and it was very informative. And there are a lot of comments in the chat box, appreciations that the session was very informative. It's very good. They're very useful. They are understanding it very clearly. Thank you so much, sir. It was an excellent presentation. And there was a question from the first part of this one is in stratified sampling, how to decide whether to use proportionate or disproportionate?
Again, it depends on the subgroups. So if you have a large domination by one particular subgroup, so then you can go for proportionate allocation. Or else if you feel that the both the populations are subpopulations are equally represented, so then you can go for equal allocation. It entirely depends on the nature. Yes, ma'am.
Yes, sir. Do we need to collect the exact sample size calculated for the study, or can we exceed the sample more than the calculated sample size for the study?
Yes, so even in the questions, it was showed compute the minimum sample size. Okay, minimum sample size. So you can definitely exceed, but you should not take too many. So you can definitely exceed, but you should not take more than twice or thrice recommended. Definitely you can exceed, but you should not come down, so you can exceed.
Yes, sir. If there's one participant is asking if there is no mean difference is given in the RCT study, how we shall calculate the sample size?
So one is you can go for pilot study. So even if there is pilot study is not possible, so what we do is, so we have the formula n equal to 2 into z1 minus alpha by 2 plus z1 minus beta square. So we use effect size. So this is referred to as effect size. So we say that point 0.2 is a small effect, point 0.5 is a moderate effect, point 0.8 is a large effect. So these are given by Cohen. So there is a person called Cohen. So he has given the cutoffs for this effect size. Point 0.2 small effect, point 0.5 moderate effect, point 0.8 large effect. So you can use effect size if you don't have any information related to the clinically significant difference.
What is the minimum sample size as per the statistics?
Minimum sample size, so there is we can't say that there is as a rule of thumb there should be so many. So again, I'm not sure of this. So I don't, as per my knowledge, there is no rule of thumb that you should have so many. So again, it depends on your objective and how much minimum difference you expect. What is the
Uh,
clinically significant difference you expect?
so what is the ideal margin of error to be considered in a descriptive study? Can be reduced from 0.05.
Yeah, ideally, if your objective is estimation of proportion, we usually take point, we start with 1%, that is 0.01, or 5%, 10%. Maximum we go till 15%. So we usually don't fix a margin of error more than 15%.
Okay, so there is one more question from the
Excuse
first
me.
part of the session. Which
Mhm.
sampling technique is best suited for a quasi-experimental study?
Quasi experimental, again, see, as it is a quasi experimental study, it may or may not have a sampling technique. So it is experimental study, no? So in quasi experimental, what we do is we divide the group non randomly. So it may or may not have any sampling technique. So in quasi experimental, what we do is we might select some two groups which are already there, something like one particular ward is a experimental group, another some ward is control group, something like that. They are already existing. So in such cases it may or may not involve sampling.
Okay, so one participant has asked from where we can find the prevalence.
Prevalence, previous studies, or you can do pilot study of your own, or you can ask some experts. So if anybody has already done research in this particular area and they have collected some data, so you can collect from the experts also.
Sir, one participant has asked on what fact assumption is based on?
On what?
On what fact
Uh-huh.
assumption is based?
Which assumption? I'm not clear with this question. I'm sorry.
Okay, sir. So that's all. There is no more questions, sir. We have covered all the questions, and there are a lot of appreciations. That
Thank
first
you.
time they had a such elaborate session on sampling and sample calculation. Thank you so much, sir, for taking your valuable time and in spite of your busy schedule and taking such an elaborate session with us. Thank you so
Excuse
much. We are very grateful.
Yes,
And
ma'am. My pleasure, ma'am. Thank you for the organizers for giving me an opportunity.
Thank you, sir. I
Yeah.
take
Yes.
this platform to thank organizing committee of CNRS for arranging such a learning platform for all of us. And I also thank all the participants for making this session more interactive. Uh, Last but not the least, being a chairperson of membership committee, I encourage all the participants to please join, take the membership of CNRS to participate in such learning sessions in sooner or later and participate in nursing research. The link and the contact details are provided in the chat box. Please consider joining CNRS. Thank you so much. Thank you, one and all. Thank you.
Yeah, thank you, Ms. Marilyn, for moderating today's session. I take this opportunity to thank the speaker today, Dr. Ravi Shankar, on behalf of Dr. Lata Venkateshan, the President CNRS, and all the committee members of CNRS and the office bearers. And I take this opportunity to thank all the participants who participated today and always participating in good numbers in all these sessions. And I hope today's sessions was useful in understanding the sampling technique and how to calculate the sample size for different types of study. And again, I hope you will join tomorrow to continue the program. Thank you very much once again, all the participants and the organizers and the speaker of the day today. Thank you.
Thank you very much, sir.
Thank you, sir.